Welcome to Lab 7. I'm going to try and show you some basics about simplifying rational expressions and performing operations with rational expressions. You may want to print out this outline and you can complete it with me as I work the problems. Feel free to pause or rewind the video as needed. Let's look at number 1. This is a very basic one. In number 1 here, we just want to simplify a basic fraction. To do that, as you may remember from earlier math courses, the trick here is to find a common factor in the numerator and denominator. So I'm going to think of this 48 over 36 as 12 times 4 over 12 times 3. Now you could certainly break this down in different ways. Some students even like to go all the way down to the prime factorization, but my thought process here was to try and find the largest factor that divides both 48 and 36 evenly, and that happens to be 12. Since it is, there's a rule of fractions that says if I can write that as 12 times 4 over 12 times 3 like I have, that's 12 over 12 times 4 over 3, and then 12 over 12 is equivalent to 1. So that's 1 times 4/3, or just simply 4/3. And at that point 4 and 3 don't have any common factors. Now if you like, as I mentioned earlier, you can go all the way down to prime factorizations on that. You could sort of step up to the 48 being 12 times 4. For example, I could notice that 2 times 24 is 48, and then 24 is 2 times 12, and 12 is 2 times 6, and then 6 is 2 times 3. Well, that stacks a lot of 2's together that way, but if you treat that and the 36 in the same manner, you can just cancel out common factors and maybe do that process that I just did in stages. Number 2 is very similar to that, except we have x's involved, but very similar sort of thought process here. Let's look first of all at the number part. I like to break this up into the numeric part and the variable part. Looking at the number part, 12 and 8 both divide by 2, but they also both divide by 4. Now 12 has a factor of 6, but 8 doesn't. So I think 4 is the largest factor that divides both. So I'm going to think of 12 as 4 times 3, and the 8 is 4 times 2. Looking at the x's, the x's will cancel if they're identical. Now I've got an x cubed and an x squared. I'm going to use the property of exponents here and split one of those x's off. Let's treat that as x squared times x to the first power. That would give us back the x cubed that we originally have up top. And I'm going to leave it as x squared down below. So what I'm trying to do there is match my powers top and bottom. Now once I have that, I can see cancellation on the 4's and cancellation on the x squareds, because those are equivalent to 1 like we saw up here, the same way that 12 over 12 was. That's going to leave us with just 3 times x up top and just 2 down below. So 3 over 2x is my result there. 3x over 2 is my result there. Let's try a couple more of these. In number 3, it's a bit different from the first 2 examples that I have here in that it has minus signs in between the terms. In fact, in the numerator of the last problem, number 2, I had product of 12 and x cubed, and down below I had 8 times x squared. In number 3, I have a difference of 2x and 6 and a difference of 5x and 15. And that's really a game changer here. what I want to be careful about is anytime I have plus or minus signs between the terms in a fraction, I always want to remember to factor first and cancel after the fact. A lot of times we get a little excited when we're able to cancel things, and we want to cancel too early perhaps. Be careful about that. In the numerator, let's just look at the numerator kind of by itself. 2x and 6 both have a common factor of 2. In fact, 2 is the greatest common factor of 2x and 6. So I'm going to factor 2 out. If I do that, it'll leave x minus 3 inside. 2 times x is 2x, and 2 times negative 3 is negative 6. So notice that my step is reversible. I'm going to play the same game down below. 5x and 15 both have a factor of 5. I'm going to pull a 5 out. If I do that, that leaves an x minus 3 there as well. Notice again, if we multiply that back together, it does give us the original problem. That just reassures me that my steps are reversible. Now we noticed in number 1 that 12 over 12 was equivalent to 1. In number 2 we saw that 4 over 4 and x squared over x squared are each equivalent to 1. Even x minus 3 over itself is equivalent to 1. So you wouldn't have to write it out this next step, but technically what we're doing here is thinking 2/5 times x minus 3 over itself, and that's 2/5 times 1. X minus 3 over itself is equivalent to 1, just like we've seen above. So that leaves us with 2/5. In number 4, we have some multiplication to do here. Now, when you multiply fractions, maybe I should mention this, when you multiply fractions, a over b times c over d, the rule is to multiply straight across. So a over b times c over d is just ac over bd. Notice that when you multiply, there's no need to get a common denominator. A bit later on this sheet we'll touch on that idea, but for multiplying or dividing fractions, you don't have to have a common denominator. You just multiply straight across. So that's what I'm going to do here. In fact, let's just go ahead and write it that way first of all. I'm going to write this as big fraction 2x times 10y squared all over 5y times 6x cubed. Once I do that step, I really have a big single fraction, much like numbers 2 and 3 were earlier on this sheet. I do have some other variables in play. It may pay us to rearrange terms a bit. I'm going to sort of do some associating here and commuting. I'm going to put the 2 and the 10 together. So let's think 2 times 10. I suppose you could write that as 20 if you like, but I'm just going to leave it as 2 times 10. And then I'm going to put the x and then the y squared. You wouldn't have to do this. I'm just trying to be organized here. Down below, I've got a 5 and a 6, and I'm going to put the x cubed next and the y. Now I've got some cancellations that I can do here. Let's think about this. I'm noticing a couple things here. Let's first of all look at the numeric part. 2 and 6 have a common factor of 2. So if I cancel 2, and by canceling I'm thinking dividing really, 2 goes into itself once, 2 goes into 6 3 times. So there's a common factor of 2 that I'm canceling out there. 5 and 10 have a common factor of 5. 5 goes into itself once, into the 10 twice. That gets the numeric portion sort of straightened out here. In fact, just to do this in steps, why don't we go ahead and write down what we have so far. We'll have a bit more simplification to do here, but let's go ahead and see what we've got so far. We've got 2 left on top, still have our xy squared, and then down below we have 1 times 3 is 1 times 2. Up top it was 2, and then down below 1 times 3 is 3, and then x cubed y. Now, much like the earlier problem, I like for my variables to have matching powers. That's how they're going to cancel out. So let's do some rewriting in terms of those. I've got a 2 over 3 still. Looking at the x's, I've got first powered x, or just x up top. I've got an x cubed down below. Let's rewrite that as x times x squared. I've got a y squared up top and a y down below. I'm going to leave the y down below and split apart. The y's up top is y times y. Now, the x's that have the same power will cancel, and the y's to the first power, same power, cancel, because those are equivalent to 1. So when all's said and done here, I think that's going to leave us with a 2y on top and a 3x squared down below. And that'll be my final result for that one. Number 5 is rather similar. We're going to divide and simplify this time. Remember, when you divide fractions, a little bit different rule over here for that. A over B divided by C over D equals AD over BC. You can sort of think of that as, I suppose, a cross multiplication is happening there. You see that? Downhill over uphill. You want to do downhill first, over uphill second. Of course, you may have been shown this a different way before. This is also true. This does equal A over B times the reciprocal D over C. I know, in fact, I was taught that way back in my early math days. So if you want to just simply flip the second fraction over and multiply straight across after that, you can do that. But if you can get used to this cross multiplying, you may find it to be a little bit faster. I'll go ahead and do it the more traditional second way here on this sheet. This next problem is 2x over 5y divided by 10y squared over 6x cubed, but when you divide with fractions, you always multiply by the reciprocal of the divisor. That's the second one. It flips upside down. So 6x cubed goes up top, and 10y squared goes down below. At that point, we're going to multiply straight across, and the rest of this is very similar to number 4. I'm going to go ahead and do some arranging here. Let's say that's 2 times 6 times x to the 4th power. Do you see x and x cubed multiply together, and we add the exponents there. Down below, 5 times 10 we'll have. I'm just leaving those separate for now in hopes that something will cancel in a bit. Y times y squared is y cubed down below. Now 2 and 5 don't have any common factors, but 6 and 10 do. 6 and 10 have a common factor of 2. 2 goes into 6 3 times, into 10 5 times. Now, looking at the variables x to the 4th and y cubed, because those are different variables, we're kind of stuck with those. We can't cancel anything out there. Our final answer will just have those parts in it. So let's write out our final result here. We've still got the 2, the 3 that remain from the 6 when we pulled out the 2 there. Everything's multiplied, so that's 2 times 3 or 6 times x to the 4th up top. Down below, 5 times 5 is 25 y cubed. 6 and 25 don't have any common factors, and x to the 4th and y cubed don't have any common factors either, so that's as far as we can go with that, I believe. So you can see some similarities here between multiplying and dividing and just basically simplifying the fractions like we did up on number 3 and number 2. Once you carry out the multiplication or division, you really have a big fraction bar that can be things can be separated out on and simplified. Common factors are equal to 1. These next couple problems are a little bit different. The rest of the sheet, I've got 3 more examples for you. 6, 7, and 8 are all either addition or subtraction. Now, with addition and subtraction, unlike multiplication and division, we do have to have a common denominator. So, remember, when you add fractions, a over b plus c over b is a plus c all over b. That is, if I have the same denominator here, I can just add the numerators and keep that common denominator. For example, if I had 1/2 plus 3/2, that's 1 plus 3 over 2, or 4/2, which is just 2. The problem we have here with number 6 is I don't have a common denominator, which means I need to get one. We'll need to find the LCD. I'm sure you've probably seen that before. LCD is least common denominator. The least common denominator is the smallest number that both denominators divide into. Looking at 2 and 5, the smallest denominator that 2 and 5 both divide into happens to be the product of the two, 10. And by the way, that's always going to be true when you have two denominators with no common factors. 2 and 5 are both prime. The product of those will be the LCD. Sometimes you have a common factor and you can get by with a smaller one, but in this case our LCD is 10. So you can do this a couple different ways. I was sort of taught to do it this way. I'm going to rewrite my denominators for each of those fractions as tens, and then I think this way. I have a 5. How many times does it go into the 10 that I want? It goes twice. So I need to multiply the numerator, which is 3, times 2. Now let me go ahead and say what that's going to be. That's going to give me a 6 over 10 for that first fraction. So you may even do that on your head if you're able to. 5 into 10 twice times 3 gives me 6. In other words, I really have effectively multiplied the 5 times 2 to get the 10, so I've got to multiply the 3 times 2 up top to compensate for that. So in essence, what I'm doing there is multiplying 3 over 5. If you think about it, I'm really multiplying 3 over 5 times 2 over 2, and we've already said, hey, that's equivalent to 1, so that's legal. So instead of canceling it out, I'm multiplying by something equivalent to 1 to get a common denominator. I'm going to play the same game with the 1/2. 2 goes in the 10 5 times, so the numerator there needs to be 1 times 5, which is 5, so that's 5 over 10. The temptation some students have at this point is wanting to cancel those out, but that'd be counterproductive. We need to have the same denominator, so we're building up on purpose to get that common denominator. Now then, I have this scenario with the same denominators. The answer should be 6 plus 5 over 10. 6 plus 5 is 11 and I keep the common denominator of 10. So 11/10 is my final answer for that one. 7 is kind of similar. I've thrown an x in there to make things just a little bit different. If the denominator involves the variable, you have to take that into account also when you're thinking of the LCD, and it just takes a bit of practice to find the LCD here. You can probably tell already that 10 is going to be part of that, just like we saw in number 6. Here we have a common factor of 5 going into both 5 and 10, so it's not really necessary to multiply the 5 and 10 together, although I guess you could use 50. Let's keep the numbers as small as possible. That's when we use the least common denominator. 10 is the smallest number 5 and 10 both divide. We also have to account for that x, though. Since x is multiplied by both of those, I have to include the x as part of the LCD too. In other words, I want my denominator to be something that both denominators will evenly divide into. And I'm going to play the same game here as I did up top before. My numerator is 3. I have to multiply that by what I multiplied the denominator against. 5x goes into 10x twice. So in essence, I'm multiplying 3 over 5x times 2 over 2, much like I did above in number 6. Of course, that will give me a 6 over 10x. For the second fraction, I've already got a 10x. The numerator is 1. I don't have to do anything to it. It's already good to go. I don't have to multiply anything against it. So it remains just 1 over 10x. And here again I have a common denominator. 6 plus 1 gives me 7 on top of that common denominator, 10x. So I believe we're looking at 7 over 10x there for that final result. Well, finally here on number 8, just to give you a little bit of variety, we have subtraction this time. And I'm just trying to use some commonality here, but you know, your denominator doesn't always have to be 10x. That's just the case on this sheet. To arrive at that 10x being the common denominator for this one as well, that's happening because 5 and 2 don't have any common factors, and x doesn't have a common factor with 5 or 2 either. So the product of all three factors, 5 times 2 times x, or 10x, becomes the LCD. That's pretty common. I wouldn't say that happens every time, but you'll find that to be a fairly common scenario. 5x goes into 10x twice, so we're going to have a 3 times 2 yet again there. Now, for the second fraction, we're going to have to build them both up this time. 2 goes into 10 5 times, and also notice there's no x next to that 2. So I had to multiply an x against that to get this 10x over here, which means I'd better multiply the numerator by that as well. Now don't actually cancel it, but in your mind, if you think cancel the x's, cancel the 5 and the 10, you should get the 1/2 back. That's just reassuring you that the process that we've used is legitimate. So that gives us 6 over 10x minus 1 times 5x is 5x over 10x. Again, tempting to cancel, but don't cancel it. We're trying to put these guys together. We keep the common denominator and we add numerators. This one's a bit different from the last guy because the numerators are not like terms. 6 minus 5x has to just remain separate. So our final answer is just 6 minus 5x all over 10x. At this point, you're able to complete the rest of the questions on this document. Be sure and go to the Math Lab if you have any questions. I do have the Math Lab website. You can click there for the hours. I have a few problems for you on that handout. Note that at the bottom you'll see the answers are there too. Good luck.